Cool. So I'm going to give a talk that actually is looking at a review of a lot of other work that's been going on in social network analysis, plus some stuff that we're doing at People Pattern. So I don't want you to go like, oh, this is all work that Jason did. No, it's actually, I read a whole bunch of things about what people have been doing in social network analysis, pulled out some of the coolest papers that I found, and then pulled out some of the coolest sort of takeaway messages from a lot of those papers. All right, so one thing I want to start with is this idea of meme tracking. This actually goes to a paper some time ago. The key idea being that I want to be able to look at large amounts of text and then pull out automatically what were the key memes that were being talked about without having to detect those in advance, and being able to detect what were the different kinds of ways that people talked about a particular meme. Say lipstick on a pig, for example. There are many different ways of saying that. And there was a really cool study that looked into meme tracking and looking at this with respect to the 2008 presidential election. And so you could kind of get this idea of, over time, in terms of responses to the debates that were going on, which memes sort of had the most sort of mind share in the news media with respect to kind of capturing these as time went on and seeing when they sort of rose up. So lipstick on a pig, for example, was the biggest spike, and it sort of kept quite a bit of emphasis all the way over, but eventually dwindles out. Now, the more interesting thing with that is this was able to reveal this sort of underlying second-order phenomenon, which was this heartbeat pattern in meme tracking. So what you'd find is that something would happen, right? Somebody would say lipstick on a pig, and there'd be this initial uptick in fraction of mentions on blogs. All right, so maybe this was a reaction to a debate, right? And so now suddenly somebody says lipstick on a pig, and somebody goes, I'm going to write a blog post about that, or I'm going to tweet it, or something like that. And you see this initial uptake. Well, then the news media sort of captures that for a while. So there you see right here, this is blogs sort of picking it up. But then the mainstream media will pick it up, and they'll sort of take over more of the actual share of that discussion for a little while, and then they lose interest and move on. But then what's cool is that the blogs sort of pick up and start talking about that for some time. There's an extended discussion about that particular meme over time. And what's neat is this is a graph derived from looking at lots of different memes over a long period of time, and then kind of normalizing to see what was that pattern with respect to the sort of onset of the meme and then what happened after, right? So this is kind of a cool thing of taking a whole bunch of just raw text and then figuring out a cool pattern like this. Now, some of that people who were involved in that project later on, like 4 or 5 years later, ended up doing a really cool study into looking at quoting patterns in political coverage. All right, and so the idea was, hey, bias is a really hard thing to measure, right? If you actually ask people about what they think about bias, you get really different answers, right? So, for example, 57% of all Americans think that the mainstream media is biased. And if you ask conservatives, well, 73% of them think that the media is biased towards liberals. If you ask liberals, 11% of them think that that bias is towards liberals, right? So there's some kind of divergence from some maybe ground truth about how biased things are, right? And we're seeing that huge divergence. And this is tied in quite likely to this thing called the availability heuristic, which is well known in literature on behavioral economics. And in particular, there's plenty of studies that show, for example, that husbands and wives estimate how much work they're doing around the house very differently. And the reason for that is if you ask a husband, well, what percent of the housework do you do? They'll think like, well, I washed the dishes, I cleaned out this, I did that. And then they kind of forget like all the things that the wife did, or they weren't even around when the wife did. Same thing when you ask the wife, right? So you have this heuristic where what information is available to you allows you to make an estimate of some underlying frequency or some proportion, but it's biased, right? So it's a hard thing to do, and you can't just ask people. So the idea of this particular study was really cool. They said, look, there's all this stuff that President Obama has said since he took office, and it's all recorded, so we have access to all of that text. Now let's go ahead and look at, well, when people quoted what President Obama said, which things did they quote? All right? And then you can start looking at knowing that some of those outlets, those media outlets, are known to be conservative or known to be liberal, or maybe they're not declared but they're suspected liberal, maybe they're not declared but they're suspected conservative. All right? And then what you can do is say, well, let's look at a particular speech by Obama, say the 2010 State of the Union address, and you can get a cool kind of graph of which parts of that speech were most resonating or being discussed in the conservative media versus the liberal media, right? And so you have, whenever there's a red spike, that means that there was something that he said that really got picked up in the conservative media. Similarly, blue spikes are ones where the liberal media really picked it up. And it's no surprise when you actually look at, like, A right here is this thing here about Al-Qaeda and so on, and that was really picked up in the conservative media. So now, here's the thing. That's kind of a cool visualization. But again, let's think about the second order effects and what's actually something you could draw out of that. Well, back to matrix factorization and figuring out what are the sort of latent explanations of a large number of variables. So you build a matrix based on what are all the things that Obama said. That's the rows of your matrix. The columns of your matrix are all of the news outlets that actually responded to that thing that he said, right? So, I mentioned that, so now I get an entry in there. And then what we can do is do the dimensionality reduction on that. And then you could look at, say, just the first two dimensions of that dimensionality reduction. You could do things like PCA. They have their own special technique that they did for this particular problem in this paper. And then you end up with a couple of very pretty explanatory dimensions. So, for example, this first bias dimension seems to be more mainstream media versus less mainstream, maybe particular blogs and things like that. The other bias dimension is more conservative to more liberal, and then on to foreign media. And it just falls out like that, right? There is no learning, supervised learning that goes into this, the building of this particular graph right here. And then what's also kind of cool is you can say, well, there are certain sites that are declared to be conservative. These are these guys that are the filled-in downward red triangles. The filled-in upward left triangles are the ones that are declared to be liberal, like The Nation and so on. And then you can say, well, how do other sort of things line up? So you see, like, Fox News, which is suspected conservative, does fall sort of a little bit on that line, but it's actually not like all the way up on the conservative line. And then the New York Times is actually not that far away from it, right? And so this is just pulling out of the data. Now, this is constructed in a particular way to be looking at just the speeches that Obama did. If you did this according to other things, like, do this for George W. Bush or whatever, you might find different constructions of this matrix, but it's still cool that the data sort of falls out like that. Then you can go another level further and say, well, what was the sentiment around the things that were being quoted about Obama, right? And then map it also into the same space. And no surprise, you find that the more conservative you were, the more negative you were. So sort of darker means that you were more negative, right? And so if you kind of map it on that space, it also makes intuitive sense with respect to these kinds of questions. So then, this makes sense, but you could start asking a lot of other questions using a very similar kind of methodology. All right, so this is, I think, a really nice example of thinking about what you can learn from a lot of documents at scale using some fairly straightforward natural language processing techniques combined with various kinds of dimensionality reduction. All right, another cool paper was, hey, let's look at structural virality, right? There's this whole idea of things going viral, right? Often companies would just love to have that viral video or post or whatever, and they're sort of obsessed by the Oreo example from the Super Bowl and things like that. Well, it turns out that you're kind of like, it's not a pipe dream, but it's a pretty uncommon thing to get those sort of really viral events to happen. And you can't kind of build yourself up for them in advance of the things. They sort of happen. But let's try to understand what kinds of situations lead to more or less viral kinds of situations. What you really want is to reach a lot of people, right? And so you can think about two extremes of how does information propagate from one source to a whole bunch of possible recipients of it. One is just a big old broadcast, right? New York Times tweets it out and a whole bunch of people get it. Or you could think of a more viral thing where I sort of tweet something out and then Steve tweets it out and two more people tweet it out, so on and so forth, right? So that would be more of what you'd think of as viral, where I'm infecting him with some information, he goes and infects somebody else with some information, and so on and so forth, right? So you have to tease apart the idea of structural virality from the idea of, can I reach a whole bunch of people? Which is what most companies who are in the sort of space of using social networking and so on are really interested in. So what this paper did is it characterized structural virality by having basically a simple calculation on these different kinds of cascades of propagation of information, saying, well, things like this where you just have one big branching event with a few like that, that's kind of close to zero. But other situations where I've got a lot of little local shares and it's a lot of high branching factor leads to something closer to 1 on the structural virality kind of side of things. All right, so this is characterizing information cascades. These are not a social network. This is who picked up what when and sort of propagated the information. All right, and then we can start doing is saying, well, what kinds of different cascades of information lead to more sort of higher virality or higher spread of information? And one of the things I just think is really cool here is that you have things like this. These are actually petitions that are out here that have the strongest structural virality. So petitions tend to be passed on from person to person rather than just one big broadcast event. And there's a reasonable sort of explanation for that, which is that people care about an issue and they want other people to get them and so on. And they're not usually going to be propagated by, say, like a big thing like the New York Times just going blah like that, right? On the other hand, things like videos tend to reach the most people because they are, sort of cool. Everybody loves to share them and all that sort of stuff, but they're not shared in as viral of a manner. So it's neat that you can kind of tease apart different ways of thinking about how an information cascade can go along, and then just think about what ways do you need to do if you really want to reach a whole bunch of people. All right. And then finally, sort of the depressing thing for the people who want their own Oreo story is that really 99% of content adoptions terminate within a single generation. So that means you get like one shot and then you're sort of done. And these big, huge image and video cascades are actually low in structural virality, which kind of means if you're a company, you got to pay to play. You have to kind of just get it out, try to get a whole bunch of people thinking about it by doing that several times. Now, you might say, like, well, but you know what? What if I'm really clever and I want to be able to predict when I see the start of something that's going viral, right? And it turns out there are some properties by which you can glean from the start of the spread of a content spread that will tell you that something is likely to go viral versus something that's not. So on the left, for example, this is just the beginning of a graph. These are actual connections of people spreading information. And these things right here went viral, whereas these things over here did not. And you can see that it kind of makes sense. The stuff on the right are these situations where a whole bunch of people who are tightly connected within a single network didn't kind of get outside of their bubble, right? But on the left, you had a lot more diversity in terms of who was the initial sort of set of people who were actually picking up on this particular thing. And it turns out, well, you can characterize these in terms of certain graph properties that allow you to predict with reasonable accuracy which given like the first day or two of a particular thing that you might think could go viral, you can predict reasonably well whether it's going to go viral or not, for real. All right. Now this is one of my favorite things. If you don't have a social network, right, you just have people who are talking about stuff, you might want to infer a social network. And the thing is, you might actually assume that the reason that I said something today and Steve said something tomorrow and then Chris said something the next day, you don't know that we're all connected and that we know each other, but you might be able to infer that if that happens enough times, right? So the behaviors that we have, especially in terms of the things that we say, can be used to go back and infer social networks. And this comes back to kind of a contagion metaphor, the idea that I've infected Steve with some bit of information and he's gone and infected Chris with some bit of information, and so on. So if I observe these kinds of events enough times, I can use a viral contagion metaphor to think about inferring those networks, right? So the key idea, if I actually know what the existing network is and I assume that node A gets infected, there's some spread that they have to the people that they are connected to. So A sort of sneezes and B and C are within reach. B and C have some probability with which they're going to get infected, and B manages to have all of their antibodies and stops the infection. But C then sneezes, and guess what? B finally gets it, and this sort of illness spreads finally through the whole network, right? And so that's, if I know the network, you can kind of look at how this particular contagion spread through the network, right? Well, now let's think back to that initial situation I talked about where all I'm observing are people getting sick or people saying things, right? And now this is, for example, somebody got sick with a common cold. Somebody got sick with the flu or something like that, right? And I've observed the timestamps at which each of these individuals experienced this particular illness. Or somebody was saying lipstick on a pig, right? Somebody was saying, make Donald Trump again. Things like that, all right? So given that sort of time course of things, the paper lays out a way of inferring the network that produced that. Cool. So now you can start looking at just large amounts of text with timestamps and start building out networks of how did that information likely spread, right? And so this is just a one spot in time graph that was constructed on, for this based on the Fukushima disaster, all right? And you can look at how that sort of spreads over time by looking at the networks that are inferred from different points in time, all right? And you can also then start doing things like, well, let's compute influence on each of those graphs. So remember, we have an inferred graph, and now we're going to do an influence computation on that. It could be a PageRank style thing or whatever you have. And then, oh, and sorry, there's also, you can actually watch these sort of inferred networks as they evolve. So you kind of have this other aspect. You can see like what's growing, what's squishing, and so on. So there might be some interesting temporal dynamics that you can pull out of that. But now, going on to this idea of, I can look at things that are, well, sorry, I got ahead of myself with the influence. First, you can start saying, I know something about a lot of these nodes. Some are just media nodes, like mainstream media. Some are blog nodes. And I can start saying, well, when did blogs tend to influence mainstream media, or when did mainstream media tend to influence blogs? And for different kinds of topics, what did that look like? So for example, with topics like NBA, you tend to have a fairly stable rate at which media passes, contagion to other media sites and so on. But also with things like Gaddafi, where you've got a sort of a rising situation, something that's happening that's really interesting. The blogs, for example, had a very big spike in terms of how much they were interacting with each other. And that makes sense, right? There's sort of a timeliness to blogs, and you can say whatever you want. You can get it out there really quickly. What I actually like even better is this idea that I can look at what's the influence of the nodes in the graphs that we're constructing over time, again, from an inferred graph. And for stable topics like NBA, the mainstream media, you can see the bigger the area up above, the more the mainstream media has the influential nodes in the graph. And it's sort of stable over time. That makes sense, right? Whereas for things like Amy Winehouse, at first the mainstream media was really not very influential in that. The blogs were the ones that were mainly talking about an event that happened around Amy Winehouse, and then eventually the mainstream media took over, all right? And similarly with the Occupy story, with Occupy Wall Street, there was a point at which the blogs took over. I think that was when the camp was being shut down right there. So now you have these other really cool second order effects again derived from text, and a social network derived from text. Now, you can step back for a second and say, well, actually, is this whole idea of virality and contagion a good metaphor for thinking about social networks? And there are some ways in which they are not good ones, right? So one is that, you've got somebody like Taylor Swift. She can, if she can't sneeze on 65 million people simultaneously. So there's a sense in which a standard way that we think about contagion isn't quite a good match. What's a more interesting divergence from how information spreads, I think, is that the likelihood of disease infection is sort of an independent event, right? If I just sneeze on Steve, if I sneeze on Chris, that doesn't, the probability of them getting sick, that doesn't change if then Joydeep goes over and he sneezes on him, right? That's just an additive likelihood. It's another chance that he has to get ill. On the other hand, if I come up and I say something to Steve and I say blah, 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 and he goes, okay, well, Jason said that. I don't know if I quite believe in that yet. But then Joydeep comes over and he says, hey, blah, 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 and independently from me, then suddenly that information seems much more trustworthy. And this is something you can even look at. There's been research in the child psychology lab at UT where they say, well, how do kids learn new words? How do they accept that a word actually refers to the thing that the person said it refers to? And it turns out if you have multiple independent parties who decide that this new thing is called a gazoink, right? If just one person says it's a gazoink, they kind of don't start using it yet. But if this other independent person says, oh, can you give me the gazoink? They go, oh, cool. Well, yeah, this is now called a gazoink, all right? And so information spread and how much you trust the information that you're getting depends also on this. So it's a non-independent kind of spread. There's also really cool things that happen. There's a neat paper that Christina Lehrman did where she looked at the friendship paradox and how that applies to creating what's called a majority illusion in social networks. All right? So there's this paradox. On average, most people have fewer friends than their friends. All right? And this is in part because there are this heavy tail of people who are very densely connected to a lot of different people. All right? And this also tends to lead to people like overestimating their friends' alcohol consumption and so on. All right. So there's a whole bunch of things around that. But there's a really nice simple graphic that they give in the paper that explains why sometimes you might think that everybody around you believes some proposition, proposition X, when in fact, the minority of people actually believe that proposition. So consider these two scenarios. It's the same exact graph. Now, the red nodes are the nodes that are sort of stating, I believe X, all right? And now you ask for a particular individual in here, if I look around and I'm on the graph on the right, and I ask, well, how many people in my local network that I have visibility to are actually saying, I believe X? Well, on the right, they say, well, only 1 out of the 4 people I'm connected to actually believe X. All right? So I estimate that not a majority of people in this whole audience or this whole network actually believe X, which is correct in this case. On the other hand, you can see where we're going. If it's the densely connected individuals who are saying, I believe X, this person looks around and says, gosh, 3 out of 4 people believe X. Dang, maybe I should believe X too. All right, so you get into these kinds of scenarios, and in the paper they do a nice study of looking into different sorts of levels at which there is a correlation between the highly connected nodes saying they believe X and how many of those nodes need to be declaring that they believe X in order for any node pulled at random to think the majority of people believe X. All right, so a simple way of looking at this is, for example, this is a line that describes that actually only 30% of the people in the whole network actually are saying, I believe X. All right? And if it's not very well-connected people who believe that, you can actually underestimate that proportion. But if there's a high degree of correlation between the people who are saying that and how connected they are, you can easily get yourself up to thinking that 70% of the people actually believe that thing. Right? So this is a real illusion. This really depends on what you as a node in the graph see around you, also based on the network structure. Cool? So you can start seeing how all that virality kind of thing is affected by human perception and like your node level perception, because you don't have access to thinking about the whole graph. All right, so that's some cool things, I think, in terms of natural language processing tied with some network analysis, even inferring networks and thinking about these things at scale. Now let's think a bit about sort of profile level analysis, where we're really interested in being able to segment people into different groups of people of different kinds of interests or different kinds of personality and different kinds of demographics and so on. So we've mentioned several times today, I think 3 times today, the Pennebaker lab, which has this Luke tool where they're often interested in being able to infer, well, when people use language in this way, they tend to be more neurotic. When people use language this way, they're sort of happier or whatever, or they're a higher status sort of individual. And Kate said it very clearly early on. She's like, we're interested in understanding the people, right, when they're asking these questions. On the other hand, I'm actually kind of the guy she was referring to, is like, I want to build a model that makes good predictions going forward. So I want to take some of those kinds of insights and say, well, can I predict if this person's neurotic or extroverted or whatever? And so there's work that's looked into, can we take things that bloggers have said, for example, and run them through, have some people actually take some personality tests, score how they are in a standard way of measuring people's personality. Then can we take the things that they've written and start looking at the words that they've used and then score them on these sort of personality scales. And it turns out you can get some pretty good correlations on these. You actually end up with some sort of more fine-grained, interesting sort of personality dimensions when you look at it purely through the lens of language. So for example, Jamie Pennebaker isn't like a big advocate of, oh, let's do big 5 personality. He actually really likes his sort of latent factors and what they can tell you. But, so now you can start thinking about personality at scale by looking at what people write. We have all these Twitter accounts. You can sort of ask all sorts of questions about these things. Jamie has a book called The Secret Life of Pronouns. Recommend checking that out if you're curious about all this stuff. And then you can start looking at, hey, what do people who score highly on neuroticism say? What do people who score lowly on neuroticism say? And that might help you think about, well, gosh, I'm a marketer and I want to be able to reach out to people who are maybe feeling neurotic about the situation. What kind of language do they use? How should I reach out to them? And I mean that in like the best sort of sense of it. Like how do we reach out to them? How do we understand that they might be in this particular state of mind? How can I understand the time course of their state of mind as they're writing reviews, right? And so on. Now here's the very practical thing, is it turns out that ad targeting, if you want to be able to get a message out to people, personality matters. And if you take individuals and you score them on a sort of a rating from more open and less neurotic to less open and more neurotic. These are standard sort of psychological terms for personality. It turns out if you're very high on the openness scale, low on the neuroticism scale, you're going to be more likely to respond to targeted ads. Cool. It's sort of as simple as that. So there's some nice results. They did a pretty careful study. It's sort of a small scale study, but they did it really carefully. I like how their methodology behind that. I'm going to skip on by the antisocial behavior online, but you can start looking at how people are antisocial. It also matters demographic variables like race. If you take, for example, things like events or entertainment, in one study, they found that Hispanic individuals they had a lower proportion of sharing about events or entertainment compared to, say, people who are white or black. On the other hand, for education in schools, people who are black and Hispanic tended to have a higher proportion of their posts about those. On the other hand, also take the whole concept of race with a big grain of salt. It's not sort of a scientifically valid concept. If you want to see one really great case, one of the best books I've read this year, check out Ta-Nehisi Coates' Between the World and Me. But it's a very fraught and difficult concept, but it's one that we end up still talking about a lot, right? Because it still is meaningful in the context of our current society. All right, so all of this leads towards the ability to do a lot of user segmentation and thinking about, well, how can I understand my 100,000 followers on Twitter at scale in terms of their interests and their personality and their behaviors and so on? And that's one of the things that we work a lot on at People Pattern. And we try to understand, for example, different persona segments within an overall audience so that you can do a better job of understanding, well, who influences this particular persona segment? Or what are the words that this particular persona segment uses compared to others? And then you can do a better job of reaching them with relevant content and hopefully have lift in your ad campaigns and so on. And so, for example, you can start doing things like, well, when people who are in a particular persona are talking about family, what words are they using? When they're talking about music, what words are they using, and so on. And then you can reach out to them and grow audiences by looking at who else follows the people who influence that particular audience. All right, so we did a lot of this work with a brand called Smarty Pants who wanted to grow their sort of gummy vitamin business. And we found that in doing a Twitter-tailored audience reach out, we had more conversions by using this sort of segment-driven content creation and targeting than when we just did sort of an average, like just randomly throw things at, say, people who looked like followers of their brand. Okay? And also there was a lower cost per conversion. And then as you think, that's sort of trying to capture lots of things at scale, but one of the cool things is when you're capturing lots of things at scale, you can sort of get down to the very micro level, right? And so just as one example I think is really cool is there's my wife, Cheryl, on the right there. She is really busy and she doesn't have a lot of time for lots of different kinds of things, and yet there's this woman, she's a homeschooler, right? We've got 2 boys and you know, she's going at it, full teaching on them. But she's got this vlogger, Teresa Jennings, who she will make sure to catch every bit of content from. And the reason is that they have huge overlap in their demographics. And in particular, like as an African American, my wife really appreciates that Teresa Jennings has a lot of the kind of like perspective that she also has as an African American mom with really gifted kids and all that sort of stuff. So there's this idea of, if you want to do lead generation, there's the let's get to people at scale, but then there's also the let's find the really micro-targeted type folks and do that at scale, right? So you can reach a lot of individuals. So to kind of wrap it up, you can do this large-scale analysis of networks and documents and reveal these really neat hidden patterns and not sort of just stop at the surface level. If you want to get your word out, you got to pay to play. I didn't really actually kind of cut out this side of things. There's this whole thing about information overload that's also really cool. And you're always fighting that fact. All right. And so that basically having this sort of understanding of your audiences is a really important thing. And one of the things that I really want to do as we sort of move forward with People Pattern is kind of bring some of that really cool analysis that people are doing on documents and so on, and bring those into what we already have, which is a really rich sort of social network with demographics and segments based on personas and so on to get better insights out of those. So that's it. I've got these are slides that I've cut from a previous thing, and I've got a blog post that actually has all of the references plus things that you guys didn't see. So, any questions?
By pay to play, do you mean that get multiple people to spread the message instead of one single person?
I think there's this whole thing that a lot of companies, like even big brands, have this idea. Well, if only like I get the right influencer to tweet out a thing or whatever, if I can just have this really clever bit of content, then I don't have to pay to get a whole bunch of people to see my message. And it's a bit of a pipe dream, really. Like you might strike gold and get lucky and have just that right video or just that right thing, but too often people are already kind of bored of a lot of that sort of thing. And so the basic point is, yes, whoever you are, you're the CMO of some corporation, you might want that thing, but you probably just really need to put down the budget and buy the space. Mm-hmm. But you might want to know who are the right people to have doing that, right? And what are the right venues for that?
So the paper about inferring the network and what people talk about, isn't that kind of like it's already determined in the data because they were in that network? So the data...
No, there's no network, right? These were mainstream media and blogs. So you're actually building a network of blogs and New York Times and things like that. That's the beauty of it, right? And one of the things we're seeing right now is that more and more the social networks are taking away access to their networks, right? Facebook has just become basically a walled garden. Who knows how long it'll be? I mean, LinkedIn has been like almost inaccessible for a long time. Twitter is the only, it's not the only one, but it's one of the ones that is very open, which is why there's so much academic research on it and many companies use it. But who knows how long it is before Twitter starts removing some of that. So shoot, if I can actually build up a network of people based on the things they talk about, well, gee, I might not need exactly that. And there might even be a more interesting graph, which is based on actual common interests than just, well, I follow that person because they followed me and they looked okay.
But again, it'll get you into the problem of, if you infer an invisible network, is it real, right?
Oh, right, and then you can start asking, can I actually do like activations? Can I do a particular ad campaign or whatever that uses that more effectively than not knowing that inferred network? But it's neat that it's possible to do such a thing, I think, at all. And that's a very non-obvious thing.
What was the tool you used to have the social network animation?
So that was work out of Stanford, the Snap Lab, and that's Yuri Leskovich. So he has all those up there, and I'm not sure what tool he used for that. Okay, thank you.